New York City weighs about 1 trillion pounds. Steel, concrete, glass, all this presses down on a thin layer of earth and rock. And he's not moving. Not an inch. Not 1 millimeter a year in most places. He just stands there. As if the ground beneath him doesn't notice anything at all. Let's make it really tangible. The Empire State Building weighs 365,000 tons. But the Empire State is just one building. There are more than 7,000 of them in Manhattan alone. And underneath it all, just the earth. And that's what's really weird. The soil on which most cities stand is not a solid monolith. In terms of structure, it is not so far from wet sand on the beach. Step on wet sand and your foot falls through. Why doesn't the skyscraper do the same thing, only slowly? Let's go back to ancient Rome. They built aqueducts, colosseums, roads, huge stone structures. And for a while they continued to collapse, not from wars, not from earthquakes. They were just sinking into their own foundations. The Romans realized something important. Not about the strength of the building itself. It's about what's underneath it. They started using pozzolana, a volcanic ash mixed with lime. The result was concrete, which became stronger from water. They made the bases wider and distributed the load. Fast forward to Chicago in the 1850s. The city was built on marshy land near the lake. The buildings literally sank into the mud, sometimes by several meters per year. Engineer Ellis Chesbrough proposed a daring solution: raise the entire city. And they did it. Chicago was physically raised to buildings, streets, sewers to a height of 2.5 meters, using jacks, while people continued to live and work inside. But what's interesting is that raising the city is an extreme. There is a simpler, invisible system that holds most cities, and she's been hiding under your feet all this time. Every city that does not sink gets three things right, consciously or by accident. First, load balancing. Spread the weight over a large enough area, and even soft ground can withstand a colossal mass. Second, soil mechanics. Proper soil or properly fortified soil can hold together and carry the load without sagging. Third, the depth of the foundation. Go deep enough and you'll hit the bedrock, a hard, ancient stone that does not shrink, settle, or shift. This is your anchor. That's the whole secret. But how these three things interact in practice is where the really exciting things begin. Imagine that you are holding a tray of eggs. If you press on one egg with all your strength, it will crack. But if you put your palm flat on the entire tray, the eggs will hold up, the same power. Different result. That's what load balancing is all about. The foundation of the building works the same way. Instead of concentrating all the weight at one point, engineers design wide concrete slabs. Slab foundations that distribute the load over hundreds of square meters. The ground beneath them hardly notices anything. But what if the ground is too soft even for that? That's when the madness begins. Engineers use piles of giant concrete or steel pins driven deep into the ground. Not to lean on the topsoil. And to completely bypass it, the Burj Khalifa, the tallest building in the world, is supported by 192 stilts, each 50 meters deep, driven directly into the rock. This is not a building standing on the sand. It's a building nailed to stone with sand as a shell on it. Now about the ground itself. Soil is not just land. It is a mixture of particles, sand, silt, clay, and the spaces between them are filled with water and air. When weight presses down, these spaces shrink. This is called precipitation. A small amount of precipitation is normal and safe. Too big. It turns out Mexico City. Mexico City is built at the bottom of a dried-up ancient lake. There is a thick layer of clay under the city, so soft and saturated with water that it almost behaves like a sponge. Over the last century, the city has sunk by more than 10 meters. In some areas by 50 centimeters per year. The buildings are tilting. Roads are cracking. The water pipes are bursting. The city is slowly being absorbed by its own soil. The reason why most cities avoid this fate is bad luck. This is geology, and the ability to read it before you start building it. That's what really happens when engineers decide to build a skyscraper today. Before lifting even one steel beam, geologists drill wells, narrow holes that go straight down. Sometimes 100 meters, to take samples of what is really underground. They're looking for the bedrock, and they map every layer of soil between the surface and this rock. The samples are checked in the laboratory. How compressed are they? How fast is the water drained? How do they behave when vibrating? These data determine everything. How deep the foundation should go, what type it should be, how many piles, and what diameter. But here's what most people never think about. The ground under the city is not static. He's breathing. In dry seasons, clay soils shrink. On rainy days, they expand. Some soils swell up when wet. They are called swelling clays and can literally push a building up. The foundations are designed taking into account the movement in both directions. And another hidden power, groundwater. Pump out too much water from the aquifer under the city, as was done in Shanghai, Bangkok, and Jakarta, and the soil particles that used to be separated by water stick together. The soil is compacted. The city is sagging. Jakarta is sinking so fast, up to 25 centimeters per year in some areas, that the Indonesian government has moved the capital to another location. Most people do not know this. 1. Manhattan's ability to hold skyscrapers is no accident. The island stands on the Manhattan Shale, one of the hardest and oldest rock formations on Earth, formed more than 450 million years ago. In Midtown, this rock is close to the surface. In the financial district, too. But between them, the bedrock goes hundreds of meters deep. That is why there are almost no skyscrapers in this strip. Not by chance. The depth of the rock has defined the silhouette of New York. Most people do not know this. 2. The Leaning Tower of Pisa is not tilted because it was poorly built. It tilted because the soil on one side, a soft mixture of clay and fine sand, sank more than on the other. Engineers noticed this even during construction in 1173. And they continued to build. Today, the tower is tilted by about 3.99 degrees, slightly less than before. Modern engineers have specially straightened it a little to slow down the tilt without removing it completely. The slope is the attraction. Take it away and it's just a tower. Most people do not know this. 3. Venice is sinking not only because of the water. She's drowning because of what they did to the water. For decades, industrial enterprises on the mainland have been pumping groundwater from the aquifer under the Venetian lagoon. The soil particles stuck together. The earth was compacting. The city was sinking. When Italy stopped pumping in the 1970s, the subsidence slowed down dramatically, but it never stopped completely. In less than 100 years, Venice has sunk by about 23 centimeters. 23 centimeters closer to the sea forever. So why don't cities sink under their own weight? Because the best of them were built where the earth was ready to receive them. Where the rock is close, the soil is stable, and the water is manageable. And where this is not the case, engineers have learned to go deeper, spread wider, and take strength from the stone below. A city is not just buildings and roads. This is a negotiation between human ambitions and geological reality. The silhouettes we admire are determined by what is underground, no less than what is above it. Every skyscraper is an iceberg. The part that you don't see is what makes everything possible. And the cities that have ignored this reality. You can watch them as slowly, quietly, as they go into the ground, which was never ready to hold them.